Uh, Good morning, Tatana. Can you hear me?
Can hear you.
Okay, fine. Thank you. And very welcome. This is the first time I think. Yeah.
Yes, because I am going to start from next Monday. So I just wanted to come in and kind of know how everything is getting set up because from next Monday I'll be taking over.
Correct. Yeah, I know that. So we'll have to wait while all the other participants will be joining.
Sure.
This week, I think the number of participation is a little bit less. Maybe not much people are interested in, uh, like the kind of programming and all the stuff. But yes, it was there. Initially, it was fine. So let's see how it goes.
Sure.
Stay with us. Stay with us. Thank you.
Of course.
So good morning, Data Power, and you can see that there are very few number of participants. So like yesterday, I guess like we need to wait a few more minutes. So that is fine for you.
Yes, Dr. Can you hear me?
Yeah, I can hear you. Yeah, thanks.
Hello, Shrikant.
Good morning, Dr. Anand. How are you?
Good.
Yeah, so we will cordially welcome Dr. Anand as well. Let's the few more, at least few more participants joining, then we will start. Okay, so good afternoon, participants, and welcome to this fifth day of the week three of the summer school. Learn how to manage research effectively. Today we have with us our next week's speaker, Dr. Anand, also as well. But anyways, Dr. Srikanth is waiting for us.
Good morning. So let's get started with the Python introduction. So last session or last class, we looked into the basic syntax in Python and how does that differ uh, with R or any other language. So maybe I can just go over some of the things which we discussed yesterday, and then we can continue from that to some new information, the syntax itself. And then we will try to write few functions in Python. So obviously this won't take in any data set itself because as in R, we did work with these microarray data sets. But uh, in Python, it's just we will not work with any data, but instead we'll just try to understand how to write these statements, doing any of the functions. And I also want to briefly show you or discuss the techniques or the different ways you can implement your Python code. And so yesterday we looked into this into your local Python shell or the your software, right? So the installed Python software, and the version is 3.11.1. So you can run your code here, and you should be able to generate your output. You can create a new document, and you can save this as .py file and reuse it as needed in future. So this is one way, right? So you can run your Python locally, or we also looked yesterday to run your code on Colab, right? So Google Colab. So that is a much more preferred way or method of running any of my Python code because you can run that interactively, and then also you can use some of the Google Cloud resources. Um, if you want to use GPU, then you can try using that, but obviously the resources are limited. But at least for now, it should be enough for you to just practice. The other thing which Dr. Chandrajit or Dr. Lahiri mentioned was about the Jupyter notebook, right? So Jupyter notebooks and Jupyter Lab, these are also interesting resources to run your Python codes. So you can just Google, right? So just Google in your browser Jupyter notebook, and you can. This is the first link which comes up to your Google search. So you can just say try Jupyter, and in try Jupyter you can use Jupyter Notebook, second option, right? So you have options for Jupyter Lab or Jupyter Notebook or Biola, right? So but you just click on Jupyter Notebook here. It is the web application to run your Python codes. It is similar to Colab, where you have these options to create a new console or new notebook. Console is just a terminal, while the notebook is the Python PYI notebook. You can create a blank notebook. You can save your notebooks. You can download your notebooks. So then you can also reopen that into any of your local Python softwares. Or you can also upload that to Collab or AWS or even yeah, obviously in the Jupyter notebook itself. Then you can run your code, and you can run the code on cells, right? So cells are just the chunk of codes in these in this notepad or notebook, or you can also run the entire notebook itself, right? So you can run the chunks of code as you go along, or you can run the entire code in your notebook. So kernel is where you can start or stop your engine, right? So if you run your code and then so for some reason it's taking some long time or it's hanged, then you can interrupt your kernel. It will just stop the execution of your code, and you can also like restart it, right? So it will just shut down and then restart. So you can do a fresh run of your code of the code. And then a few other things which you have like help, where you can read more about how to run the code or how to access other options from Jupyter. So you can also try to run your code on Jupyter Notebook, and I can just share like some things which I do on this, right? So for example, I can open a new notebook here. So it will take you to this uh, new notebook blank page, and then you can select your kernel. So kernel is just an engine, right? So we want to run our Python code, so I'll just select this default Python option as a kernel, and it will create a notebook with this blank untitled IPYNB format file, right? So this is a interactive Python notebook. So IPYNB is interactive Python notebook. It's not a PY file, right? So if you store your file locally from your Python shell, then that would be a .py file. This is a IPYNB file. That's a little different. But sometimes you may have an incompatibility issue if you try to read the IPYNB file into your local Python program. But then you can convert your IPYNB into PY file, and then that should be able to import the file there. But then you can just rename this file as any name which you wish. Then it will just rename, and it gives you these cells, right? So these are called as cells, um, or just blank tabs here, where you can write your statements, Python statements, right? For example, you want to print, say, this is summer school, right? And then once you have your statements in this cell, then you have these options on the tab, right? So you have play option, which is essentially is a run option. Then you can pause or interrupt your kernel. Then you can restart your kernel, and then restart the kernel and rerun all the cells and few other things, right? So once you have your code here, you just run the play button here, right? Play tab here, and it will run, and it should generate an output. Um, hmm. Uh, okay, so let me just get back to this notebook here. For some reason, I'm not able to run there, but this is the same cell, right? So print, this is summer school 2023, right? So you write your statement in this cell and then you just hit play and then it will generate your output, right? So this is summer school 2023. So anything which you run on your console here, right? So print, this is summer school. This is summer school, right? So this output you will get below the cell, below each cell. So you can write your code in the entire cell, right? In this one cell, or you can create different cells, right? You can create different cells and you can run each of these cells individually or collectively, right? So this is also an interesting way of running your Python code, but I prefer Collab, and because Collab you can import or export your code to GitHub, right? So we know what is GitHub now because I have all of your repositories on GitHub. So you can connect your Google Colab Python IPY notebooks with GitHub directly. So any modifications or additions or changes you do in your collab can be pushed to your Git repository. So that is a very neat feature of using Google Colab, which I like. There should be option here. I don't know from Jupyter Notebook. I think you can connect to GitHub. I don't use that, so I don't know. But if you want, I think what you can do is you can just save the notebook and then you can upload this notebook to your Git repository. So you can probably, that may be one way of pushing things to your Git repository, which is to save your notebook locally and then update or upload that to your Git repository. So that's just one way. I don't know any other way to do that, but definitely there should be some way to connect Jupyter notebooks to Git. All right, so that's with Jupyter Notebook, right? It's very easy. You can just Google Jupyter Lab or Jupyter Notebook, then you can create a new and then you can run these and then save. Make sure to save, right? So save the notebook, because if you don't save it, then you lose. If you close this browser, then you'll just lose your work. So make sure you save as you write your code. All right, so that's with Jupyter Notebooks. If you have any issues with Google Colab or Jupyter Notebook, please do let me know, and I can help you with setting up these notebooks. And also, obviously, it's free, right? So Colab is from Google, but there is some limit to the resources, right? So the amount of space or memory or the units or the runtime, they are limited. But I feel like at this point it's sufficient for you to practice. All right, so moving along, I'll just brush over these few things which we practiced or discussed yesterday. So the plan is I want to finish up this program here on the Python syntax, and then tomorrow we would do like we'll try to work on a function. Okay, on function on doing a task. So that would give you a feel of how to write functions in Python. So yesterday we looked into basics things, right? Like print statement or an if statement, and then what are variables, then what are different data types, and And then I guess we stopped at different data types, right? So different data types, those can be like say strings, where you pass a string in double quotations and you assign that into a variable. So in this case, the variable is called as x, and we have assigned a string called hello world to this x. You can also assign integers, which are whole numbers, right? So 20, 100, 1,000, million. So whole numbers are int values. And then you can also add digits or floats to these variables. Um, then indentation, right? So indentation, I hope you may have like practiced or just looked into these differences, right? One of the difference, the one of the most like important difference between R and Python are these indentations. So if you mess up these spaces after if statements or for loops or while loops, then your Python is going to throw you an exception. So, and I guess most of the times I personally make these errors of indenting because I work with R, and then if I move to Python, then I miss into some of these very basic syntax errors. And then we looked into some of these we probably just discussed what are Boolean variables, right? So Boolean values or variables are just the strings. So true or false, right? So Boolean is essentially binary. It means the statement can either be true or it can be false, right? So Boolean means binary, true or false. So I have this one very basic if-else statement here, and in this statement, I'm assigning values to two variables. So one variable is A, and I'm assigning a value called of 200 to A variable, and then the other variable is B, where I have assigned a value of 33. Right, so A holds the value of 200 and B holds the value of 33. So I want to write an if-else statement where if B is greater than A, which is false, right? B is 33 and A is 200. So I want to check if B is greater than A, then you just print B is greater than A. Print a string, B is greater than A. Else print B is not greater than A. Okay, it's a very simple if-else statement where I'm just doing I'm just checking a condition, right? A condition if B is less than A or if it is greater than A. Now B holds a value of 33, which obviously is less than A. A's value is 200. So if B is greater than A, which is false, it will print B. It will not print B is greater than A. It will print B is not greater than A, right? So let's try to run this in our Python console, right? So A holds a value of A holds a value of 200 and B holds a value of 30. So I want to write an if-else statement. If, right, it starts with if. Give a condition of if B is greater than A, close the bracket, to give your colon, and then you hit enter. Right now you see the indentation here again, right? So if you miss this indentation, then it is going to throw an exception. It starts with the next line starts with and space, where you write your print statement. Print B is greater than A, colon, close. Then I want to write a else statement because it's an if-else statement. if this is true, you do this, else do that. That's your if-else statement. Then I hit enter. And now, now you see, once you hit enter here, it still follows an indentation, right? So it still starts after a space. But this is incorrect. Now the else statement should again start with if word, right? So the else would be followed at the same line as if, right? Else print a, b is less than a. Okay, this is a little tricky, right? So after the print statement, if you hit enter, the indentation will go below print statement. But that would be wrong because if and else are the keywords. So if starts at this position, then else keyword should also start with that same position. And if I do else following the indentation after if, this is going to give me an error. Right, so keywords should start at the same position, and that is what it does here, right? So you need to just correct this after your first print statement. So let's run this. Let's see if it generates the output what it's supposed to generate. All right, so it gave me some error because let me just run this individually, right? So then I'll just copy here and then you get your output. Okay, so you first type in the value of a as 200, then you type in the value of b as 30, and then you type in your if-else statement where if b is greater than a, then print b is greater than a, else print b is less than a. And since the value is of b is less than a, then it will print b is less than a. Okay. So this is called as conditional testing, right? So if the condition is true, it will produce something. If it is false, it will produce something else, right? Conditional testing. This is a very basic if-else statement, but there can be complicated statements, right? You can have multiple if statements, right? If b is greater than a, if c is greater than b, or if, right? So you can have if you can have many if statements here, right? So you can add multiple testing statements to produce or to test or check and then print the desired output. But this is the basic syntax of writing an if-else statement, and I would suggest you just practice and get familiar with the keywords, right? So if is a keyword, else is a keyword, and one way to note the keywords is the colors, right? So if color is orange, else color is orange, meaning these are keywords. So the keywords normally they should start at the same point on the sentence. All right, and all right, so that's all. It's with the if-else statement. I'll just stop here for a minute if anyone has any questions or any confusion.
Dr. Srikant?
Yeah, Dr. Ivar.
Yeah, I actually, typed all the commands what you told, okay, especially the Boolean one with if and else. But at the end, I'm not getting the output like as you have got b is less than a. Okay, somehow it's not reflecting.
Okay.
The only,
Did
the
you try
only
to run this individually, right? first run A is 200, then enter, then run B is 30, enter, then you run, copy this entire if else statement, and then
Okay.
hit enter. Try running it individually.
Okay. Let me see this one.
Yeah, so it is little different from R because in R you can just copy everything, put it on your console and hit enter, and it will generate an output. But Python, you have to probably run statements, single statements.
Right. So it's trying to do that.
Okay. Still not working?
Yeah, just a second. I don't know the other has all have fallen or not. Yes, it works now. Yeah, fine.
Okay,
But
yeah. So I guess the error would be if you try to run multiple statements, then it is not able to differentiate each statement, right? So it is not able to follow when one statement ends and the other begins. So just try to run them individually, and hopefully that should work.
okay, is it just one quick related query? Is it always like this in Python? Whatever commands you're doing or whatever program or we are running, okay, or whatever commands do we have to always put each and every command individually?
Uh, right. So there is a way to separate the statements, but I'm not able to. Yeah, there is a way to separate these statements and then run everything at one go. But I can look that out and then let you know how to do
Yeah,
that.
why actually why only I ask you because sometimes if the commands are more, okay,
Mhm.
for example, if you're trying to look into a complex thing which is comprised of many commands, okay, then putting each and thing and then running it might be a little difficult, or
Yeah,
otherwise
it is
uh,
definitely. It is little. So let me try this. Okay, so the other way to do that is, say if you have all these statements in this document, right? And
right.
after every statement, I give a semicolon. Do you see a semicolon after every statement here? I
Yes,
just
yes.
change the code, and after A, I give a semicolon. After B, I give a semicolon. And then I go to my run option here, and I do a run module. So I'm not
Okay.
sure what is the option you have on Windows, but then there's for me, on Mac, you have a run module option. So
Yes,
I
yes, it is
click,
there. It is there.
okay, so then if I click that, then it will run the entire code in your notebook, and you don't have to run that individually, and then you'll get your output directly.
Okay, okay, fine. Yeah, I think that solves it. So we can actually do that, even if the
So
long. Yeah.
yeah, so you don't have to run this individually, but I try to run them individually because if I have like any error, I can catch that.
Yes,
Like in real time, right?
Yeah, because if it's long one and if there is some inherent, especially error, especially in the initial step, we might, we might lose track on what went wrong. Actually.
Yeah,
Anyway,
exactly. Exactly.
thank you
Yeah.
very much.
Awesome. So that's with your if-else statements. The next thing which I want to discuss are these operators, right? So operators, as the name suggests, they operate on something to produce an outcome or an output, right? So there are different types of operators, and I'm sure you know these, right? So an operator can be, say, plus operator, which is addition. An operator can be a subtraction. An operator can be multiplication. An operator can be division, right? So these are different types of operators. You can add things, you can subtract things, you can multiply things, you can divide things, right? So for example, I want to just print uh, the addition of 10 uh, plus 10. Will this work? Right, so that works. So I just want to add two numbers, number 10 and number 10, right? So I'm using an operator called plus, an addition sign. I pass that into a print statement and it will print me a value of 10 plus 10, which is 20, right? If I want to do, say, a multiplication of 10 and 10, then I'll just do 10 multiplied by 10, or it's a star sign, right? So you pass the star sign, you run it on your console, 10 multiplied by 10 is 100, right? So these are basic operators which you can use in your functions to perform different tasks. One So I guess that is the simple explanation of what are operators, and how can you use in any of these functions. So the function which you're using here is print statement. You can also pass these operators in other functions like if-else loop statements or for loops or while loops and so on. So once you know operators, then I want to discuss about the list, right? So what are data frames? What are data frames? So a data frame is just a structure, right? It's a structure which holds the data. So in R, we can have like a data frames which can be like a matrix or it can be a list. And the concept is similar in Python, right? So in Python, you can also have similar data frames like a matrix or a list or a vector and so on. Right, so most commonly used data frames, at least for me, are list and matrix. Right, so what is a list? So as the name suggests, list is something which will store things, right? It will store some elements in its structure. So this is a list, right? So it will store some values or some strings, some letters, characters, some information in a one-dimensional array, right? So this is a one dimension. It just has one dimension, 1, 2, 3, 4, 5. It's one dimension. While matrix can have multiple dimensions, right? So you can have like 2 dimensions. So it can be say A, B, C, D, and you can have value 1, 2, 2, 4, some random numbers, right? So this is an example of a matrix, something like this, right? So it's a multidimensional structure called as a matrix, and it has these different cells, right? So A1 cell, A2 cell, B1 cell, B2 cell, C1 cell, C2 cell, D1 cell, D2 cell. And these data structures are meant to use according to your data or the analysis which you want to do on the data. right? So the very basic form of a data frame is this list, or a list data structure is a list. It's one dimensional to hold a bunch of elements within its structure, right? So just to give an example of a list, I can create a list in Python by just saying, assigning a variable. So let's assign a variable called list. And in this list, I will assign some values, say 1, 2, 3, 4, 5. I want to create a list which will hold values or elements 1, 2, 3, 4, 5, and the name of my list is list, right? So let me just run this on my console. You should not have any error, right? So you can see that there is a variable called list. It is a data structure which will hold some elements, and in this case it is holding the integer values 1, 2, 3, 4, 5, because these are whole numbers. So this is stored as a variable. So you can take this variable and you can do n number of things with this variable. Say for example, I just want to print this list, then I'll just do print of list, and you will see the elements in this list, right? So you can use this data structure and then you can pass it through any of your analysis techniques or loops, and then come up with your desired output or outcomes. So list is the simplest data structure to hold one-dimensional elements, okay, or elements in one dimension. And in this case, we are using int, right? Only the elements which are integers, but you can also hold elements which are not integers, or the mix of integers and strings, or mix of integers and floats. Say for example, I want to create a list, and I'll just name it as list mix, because I just want to make it I just want to create a mixture of elements, and I want to create a mixture of elements with numbers and strings. Numbers and string. Numbers and float. Okay, so let me just try to run if I can create a mixture of these elements, and it does without giving me an error, right? So this new list is mixture of different different data types, right? Different data types. So one is the int data type, then the letter 1 is the string data type, then 2 number is again int data type, and letter 2 is the string data type, 3 is int, and 9.8 is a digit or a float. So I can pass mix of these elements and then store it in a variable called list.mix. And if I want to print what is in list.mix or list underscore mix, then I'll just do print statement, and you will get the elements list in this list underscore mix structure, right? So it's very flexible. But if you do this in Java, it is going to give you very serious exceptions, right? Errors, that this list should be of only int values. Why did you put a string value in it? Or why did you put a float value in it, right? So just like if you're working with any of these object-oriented languages, then it's very specific. If you want to create a matrix, that should be essentially a matrix on, say, integers only. Or if you're creating a list, that should be very specific to floats only. But in Python or in R, you have a flexibility of creating these data structures with different data types. Okay. So you can just practice, right? Just get familiar on how to create a list, how to create a matrix. I'm not going to discuss how to create a matrix, but this is a matrix, which is little complicated here because you have more than one dimension, right? So you can have like 2 dimensions, 3 dimensions. So you can have n number of columns or n number of rows. In this case, you just have one row, right? One row. But in matrix, you can have more than one row, which adds a little complexity to your data structure. But if your data structure is cannot like be holded in the list, then you have to use a matrix, right? So so that's your very basic or the most commonly used data structures which are list and matrix. Okay, so I'll just wait here for a minute, and if you have any questions, please ask me. Okay, so all this code here, right? All the practice statements are on my Git repository. So if you go to my 2023 summer school repository, I have a file called python basics.py. So all of these statements I have written in this file. If you just want to have a reference or practice, you can visit this and then try to see for your reference. The last thing which I want to discuss today is how to pass this list into an say if-else statement or maybe a for loop. Okay, let's pass it into a for loop. Right, so we looked into an if-else statement before, right? So if-else statement is just a conditional testing where if something is true, produce an outcome, else produce a different outcome, right? If this is true, produce something, else produce something else. There is another loop, a commonly used testing loop called for loop, right? The for loop is where, say, I have a list of these elements, okay, in a variable called list underscore mix. I can just do a print statement to print what is present in this variable, right? So as we did here, I just do print list underscore mix, and you'll get the output of the elements which are stored into a list underscore mix. I can also use a for loop, right? So just to give you one example or a use case of using a for loop, I can use a for loop to print the elements in variable list underscore mix, right? So how to do that? So I just do for x in list underscore mix, list underscore mix, and I'll do just print x. Print x. That's it. So let me just run this for statement here, and then it will print the elements in your list. So what is happening here is we are using a for statement and we are trying to select each element in the list. So for x in list underscore mix. So what does this mean? That for x is each element, for each element in this data structure called list underscore mix, print each element. X is assigned as each element, right? So x first starts with 0. So 0 value is 1. Then x position is 1. 1 value is string 1. Then x position is 2. 2 value is number 2. Then X position is 3. 3 value is string 2. The next position is 4. 4 value is number 3. The next position is 5. 5 value is 9.8. So it is just assigning the position for X. Position 0, position 1, position 2, position 3, position 4, position 5 in the data structure list underscore mix. Print that value or in that position. Print X. Right. So if you just run this on your console, then you should have the output with the list of elements printed in the sequence, right? Because this works with position or a sequence. So it will look for first position, it will print. It will go at second position, it will print. It will go at third position, it will print. It will go at fourth position, it will print. So it is a for statement which will do things in a sequence. A print statement will do everything at once. There is no order or sequence in print statement. So I hope you appreciate the difference between a print statement and a for statement, right? So print is everything you get on one line, it is just printing everything as is. While for, it is checking for each position. And this is one of the use case of using a for loop, but this is how you use a for loop on a list data structure. Okay. All right, so I'll stop here and we have, I guess, 5-10 minutes. So if you have any questions, you can ask me now. And I would suggest you to just practice and then also run this on your Jupyter Notebook or Google Colab and see if you can, how to get familiar with using these online notebooks. And then tomorrow I will go over some more statements for conditional testing, and then also an problem, right? A problem where you want to print something, right, from a list of elements. So that is we will do tomorrow, and then I'll try to summarize the syntax collectively. All right, that's all I have. Dr. Larry, any questions?
Well, the point is, I was thinking whether the matrix that you had shown, would you like to call that in the form of an array, or what is it?
So, yeah, it can be called as an array. It's a multi-dimensional array because you have more than one row, right? So in the list, you have just one row, and it holds value 1, 2, 3, 4, 5. But in a matrix, it can be called as an array because it has 4 rows here. So first row is A12, second row is B24, third is C14, D24. So in order to work with these arrays or matrices, you need to use positions differently, right? So in this case, in a list, this is your 0 position. This is your first position. This is your third position. But you cannot use this positional assignment in arrays or in matrices, because you can have this as first position or 0 position, first position, second position. Then what would you call your second row? So in this case, you work with something called cells, right? So this is your 0 cell. This is your first cell. This is your second cell. This is your second row 0 cell, right? So to assign or positions in an array, you do something like this. So this can be your
Yeah, correct. So maybe we can discuss this tomorrow a little bit in detail so that people can get the flair of how to create an array. Maybe tomorrow, maybe you can show us. I think that would be fine, I guess, instead of now, because it's like now they've just understood a little bit. Tomorrow, I think they'll be able to grasp that a little better. What do you
Yeah,
think?
definitely. Yeah, I didn't touch upon the arrays because it's little tricky
Yes.
because this is how you assign the positions. You
And
need to consider two elements, right?
yes, correct.
Right.
And maybe also you can also just briefly, very briefly, touch upon calling upon the libraries and what are the functions of each of the libraries. I mean, just one word may be sufficient so that they get a very brief overview of everything. That's it. Okay.
Yeah. Okay. Yeah. You can discuss that tomorrow. Yes.
Yes, I think that should be fine. Okay, then. I mean, I've been only asking questions. I do not know whether the other participants would love to ask other questions or they have any doubts. So if you have any, you can please continue asking now, or else you can put them in the group as well, as I've been telling you since day one. Or else you can put back in the feedback form also. Maybe that could be the next timer. Anyone, should we call it off?
Yeah.
Anyone? Yeah, if there's nothing, then we just call it off right now. And thanks everyone for joining us and being patient to get the glimpses. Next week, or rather, the coming week, we'll get along with Dr. Anand. He's here with
So
us.
I just wanted to say that, thanks to Dr. Lahiri and the entire team for this excellent summer class. And today is one of my first classes that I attended. And Dr. Pawar, you did an excellent job. Great class today. And Dr. Pawar and I interact almost daily, and we try to understand how we can enrich this program. So next week, I'll be starting mine, and after discussing with Dr. Pawar a lot, the structure that I have come up with is on Monday, I'll be starting with the principles of genome engineering. The second day, I'll go deeper into CRISPRs and anti-CRISPRs. And the third day would be on-target and off-target analysis of CRISPR and how CRISPR is being used in the clinic. Then we'll go into protein engineering, but before that, there'll be a introduction to next generation sequencing, because next generation sequencing is used in both genome engineering and protein engineering. And then we will go into the protein engineering part. So looking forward to it, excited about this opportunity, excited to meet the faculty and the students, and I look forward to next Monday.
Thank you, Dr. Anand, for your quick briefing. And thanks, everyone. Thanks, Dr. Shrikant, for this wonderful session today also as well. Everyone, have a nice evening. Thanks, Dr. Anand and Pawar. Have a nice day.
Bye-bye.
Bye.
Thank you. Bye.